Next, we will simplify a series RL circuit and we will obtain this value. So here, as per this problem, we have a series RL circuit where the value of the resistance is 2 ohm. So value of R is 2 ohm as per this problem statement, and the value of the inductance is 1 millihenry. So value of L is 1 millihenry. That means 1 into 10 to the power minus 3 Henry. And as per this problem statement, here the expression instantaneous value of the voltage is given, and that is V is equal to 311 sine omega t. So here voltage has been taken as a reference, and we know that this is Vm sine omega t as per the format of that voltage waveform. So this measures the peak value of the voltage. So from there we can say that Vm will be equal to 311 volt, and also it is given that a 50 hertz sinusoidal voltage, so the frequency of the supply voltage is 50 hertz. So we can also say the frequency means linear frequency it is, since the unit is given in hertz, so small f is equal to 50, and that is hertz. From this given information, we have to obtain the phase angle between applied voltage and current flown through that RL circuit. Now we have seen in this class itself that the phase angle is tan inverse omega L by divided by R for a series RL circuit. So here it will be tan inverse, then omega value it is 2 pi f. So to the pi we approximate generally to 3.14, and the 2 pi f linear frequency which is given as 50 hertz, then the inductance value which is 10 to the power minus 3 Henry divided by the resistance value which is given as 2. So if we put this value, it will be 50 multiplied by 2, it will be 100, and so it will measure 314. Then 314 multiplied by 10 to the minus 3 divided by 2, finally it will be tan inverse 0.157. So angle wise it will be 8.92 degree. Then the second requirement is to find out the second requirement is to find the RMS value of the steady state current. Now current value we want to find, and in the expression the voltage value is given. So using voltage value, if we want to get the value of the current, then first we have to find the impedance value of that RL series circuit. So in the next step, what first we will do is we will find the impedance value, and that is expressed as R plus JXL. Now R value V is 2 ohm plus JXL J, and XL value is omega L. So it will be this much. So it will be 2 plus again J and omega is 2 multiplied by 3.14, then F which is 50, and then L value which is 10 to the power minus 3. So finally it will be 2 plus J, then it will be 0.314. This is represented in rectangular form, and if we want to convert this to polar form, then it will be finally, we know the formula or the relationship between rectangular and polar format, so I am not again repeating that step. So it will be finally 2.03, and angle wise it will be tan inverse 0.314 by 2. So it will be 8.92, and definitely the angle, the phase difference that we have already obtained here in the first step, the same angle we will be getting here, because here the angle that we get is the measurement of the phase angle only. So this is 8.92 degree, and this is the value of the impedance. Now by using this impedance value and the voltage value that which is given in the problem statement, we will first find out the peak value of the current. Peak value will be the peak value of the voltage divided by the impedance value. So peak value of the voltage is given as 311. So it will be 311 divided by the impedance value, which is 2.03 and angle 8.92. So it is in polar format. Already it is given in polar format and we are dividing, so it will not, we don't have to convert this. And 311, since it doesn't have any angle here, so that will be, or that can be taken as 0 degree. So simply it will be 311 divided by 2.03, and that will give us 108.33. and angle wise what we will do is we will just subtract this 8.92 from 0 degree. So angle now will become negative, the same value, but it will be with negative sign, 92 degree. And definitely the current, the phase angle in the current value will have negative sign only, because we know for inductive circuit current lags voltage. So voltage, if it was taken as reference, then with respect to that the current has to lag. So that's why here the angle is minus 8.92 degree in current value. So this is the peak value of the current, and what we wanted to find is RMS value of the steady state current that flows through that RL circuit. So we know that RMS value of current or voltage is the peak value divided by root 2. So here it will be Im divided by root 2. So the peak value we have already found, and that is 153.2, and angle wise it is minus 8.92 degree, and that will be divided by root 2, which we approximate as 1.414. let it be root 2 here. So root 2, and finally this value of the RMS value of the current we will get as 108.33, and angle wise that will remain same, which is minus 8.92 degree, and the unit will be ampere. So the RMS value of the current will be this value. Now the next is expression of the instantaneous current. Now instantaneous current, the third requirement is I. We express by small letters, so it will be I, and that it will be equal to Im then sine omega t, and since voltage has been taken as a reference, so with respect to that current will lag, so it will be minus theta. Peak value of the current we have already obtained, and that is 153.2. so here we will write 153.2, and since the phase angle, the phase difference we are including here within this sign, so we will not be writing here the angle once more, rather it will be only, we will write the peak value, the magnitude, and then here it will be omega t minus the phase difference between voltage and current, which is a minus 8.92 degree. Or we can think this way also, that I will be Im sine omega t plus theta, where theta itself is negative. So finally when we will represent, then this value will be, here it will have negative sign, then the phase difference value. Now the fourth requirement was for this problem, total active power consumed by the circuit. Circuit means the R part plus L part, the total active power consumed by the whole RL branch. We know the active power consumed by any circuit, that is equal to V, the voltage drop across that for this RL series circuit, it will the voltage value, then multiplied by the current value, and then cos phi or cos theta. So this is the measurement of active power, and the unit is watt. Now here the V and I, this voltage is the RMS voltage and I is the RMS value of the current. So peak value, as we have seen, it was 311. So 311 divided by root 2 will be the RMS value of the voltage, and RMS current value we have already obtained in the second step, and that was 108.33. so it will be 108.33, and cos of theta value, Theta here, since it is cos, so whether we write theta as negative or positive doesn't matter. Finally, we will be getting the same value only, and the phase difference, that is 8.92 degree. So finally, the value we will be getting 311 divided by 2 multiplied by 108.33, that will give us the value 23,822.87, and this cos factor, this cos 8.92, will give us 0.988, this value. So finally, when we will multiply these two values, the value we will get will be 23,534.75 watt, or we can express in kilowatt also. So it will be 23.53, and then we can write 5 kilowatt. This is the power consumed by the whole RL circuit. So this was the explanation of series RL circuit. In my next class, I will discuss about series RC circuit. With this, I end today's class. Thank you.